In this video, we're going to find the equation of the slant asymptote of a rational function such as this. Well, remember the rules. If you're going to talk about horizontal asymptotes, first of all, if the degree of the numerator is less than the denominator, then you're going to have a horizontal asymptote y equals 0. Now, when I'm talking about these degrees, alright, when I say that if the degree of the numerator is less, so that's like if I had 2x plus 3, and then I had 3x squared plus 1. Okay, here the degree of the numerator is less because the degree is 1. Alright, it's just plain x. Down here the degree is 2 because it's x squared. So in this case, the horizontal, the x-axis would be the horizontal asymptote, y equals 0. Alright, on the other hand, if the degree of the numerator is equal to the denominator, then you have a horizontal asymptote at y equals a over c, leading coefficients. So in other words, say if this was also x squared. Now the degrees are the same, so now the horizontal asymptote is y equals 2 over 3. Okay, so you have a horizontal line 2/3 of a square up. Now, what if the degree of the numerator is greater than the degree of the denominator? So in other words, what if this was x squared up here and x down here? Well, in this case, there will be no horizontal asymptote. There is no horizontal asymptote. However, there might be a slant asymptote. Alright, it won't be horizontal, but there might be a slant asymptote. So when is there a slant asymptote? Well, there's a slant asymptote when the degree of the numerator is 1 greater than the denominator. So in this case right here, we would have a slant asymptote. And you can find the slant asymptote by doing division, either synthetic division or long division, and not including the remainder. Whatever you get is going to be the slant asymptote. So this would have a slant asymptote. Okay, if this was even bigger, alright, like say if this was third power, well, that's more than 1 higher. So this wouldn't have any asymptote at all. Okay, so again, if I want to find the equation of a slant asymptote, so first of all, notice that the degree here is 1 more than the denominator. This is 2, this is 1. So we're expecting it to have a slant asymptote. We just need to do the division. Now, when we do the division, it's important that we not get a remainder of 0. If you go to do your division and there's no remainder, that means something canceled out. Alright, that means it divided evenly. And if that happens, then what you have is a whole, not an asymptote. So let's just do the division. Just make sure you do get a remainder. So when you do the division, you know, you're thinking this. You're thinking x minus 2, and it's dividing into x squared plus 2x minus 3. Now I could do long division, alright, there's nothing wrong with that. But I could also do synthetic division. Alright, and that's where I just use the coefficients, the 1, the 2, the negative 3. Alright, I leave a space. Alright, here's where the remainder should be. See that x minus 2? Alright, when I do my synthetic division, I'm going to do a positive 2. And what I do is I bring down this first 1. 1 times 2 is 2. Put that here. Add these together, you get 4. 4 times 2 is 8. So I get 8. If I add these together, I get 5. So I do have a remainder of 5, which is necessary. If this had been 0, then I wouldn't be looking at a slant asymptote. I'd be looking at a whole. Anyway, if I put the variables back in, then what I'm looking at is y equals x plus 4, all right? Because this is like 1x, you know what I mean? It's like, so it's y equals x plus 4. So this is my slant asymptote right here, y equals x plus 4.